Let us continue to learn about the Oracle query languages. In our previous class, we talked about that the query languages consist several groups of the operations. Starting with the unary relational operations, we talk about the most basic select, from, and where. To refresh your memories, let us take a look of an example introduced in the class so that you will know how would you able to combine the select from where with those and, or, as well as the parentheses together. So here is the example provided by the book. Select the tuples from all employees. So they are interested in the employees who either work in department number 4 and make over $25,000 per year, or work in department number 5 and make over $30,000. So you can see that there are several operations need to be combined together. Still doing the select from and where operations as the backbone of the query, you need to find out that how would you able to find the people who is making over 25,000 also work in department number 4. So there are two conditions need to be AND together. There's also another condition that is department number 5 and make over $30,000. Another two conditions need to be AND together. However, you only need to get one of the conditions satisfied because it's a either or over here. So for the query languages, what you will be able to see is that you will need to do basically select first name and last name because we're only interested in the employee names. And from the employee and looking into where DNO equals to 4 and salary greater than 25,000, parentheses that indicating the first condition. The second condition is DNO equal to 5 and salary greater than $30,000. Another condition, parentheses, and put an or in between indicating this can be either this case or the other case. Let's directly copy and paste the code into Oracle and then see what's going on over here. So if we're going to copy and paste into the Oracle, what you can see over here is that I intentionally leave the semicolon. So once I hit the enter, you can see that it will directly go into line 4 and then blink it over here, indicating that it is waiting for a semicolon to tell it to execute the code. So if I put a semicolon over there, hit enter, you can see that those are the three people satisfying the conditions. And therefore, that's how we will be able to answer the questions using select from where combined with and or operations. So for the query overview, binary, after we looked into the basic operations, now it is more interesting to look how would we able to look into two or more tables together. How can we combine things in two different tables? To discuss that in detail, we need to start looking at what we call a Cartesian product. Then we will be able to move into the join operation. These two important things are the main focus of the class today. So let's take a look of the Cartesian product. Cartesian product. This, as I always introduce my students, is like a monster operation. Why I'm saying it's a monster operation? Because it will generate a huge table. Let's take a look at this. This operation uses to combine tuples from two relations in a combinational fashion. So what's going on over here is saying that I have two tables and I want to put them together. So we have one table indicating is a R table, the other table is the S table. Inside of this R table, it has several attributes. So it has A1, A2 until AN attributes. So there are N attributes for table R. For S table, it has B1, B2 until BM attributes, and therefore there are M attributes in the S table. And therefore, if we try to do the Cartesian product of the two tables together, what's going on is that, first of all, it will create a huge table. That table has all of the attributes coming from the the R table, as well as all the attributes coming from the S table. So it will form a huge table with the attributes coming from the R table plus all the attributes coming from the S table. And therefore, it will have N plus M attributes. That's not only it. it's actually making even more interesting things in the next slide. So the resulting relation state has one tuple from each combination of the tuples, one from R and one from S. So what does that mean? That means not only the table will be created in a fashion that the table will have all the attributes coming from the first table and all the attributes coming from the second table. More interestingly, it will create a combination of first table's tuples multiply all the tuples in the second table, so that you can create a combination of every possible combination of the two tables. So hence, if R has n of R tuples denotes by R, number of R equals to n of R, and S has the same thing, then the number of tuples will be the number of tuples in R multiply the number of tuples in S. So you can see that it's really a huge table. You may be curious, why are we doing that? What this trying to do is that it try to create a table that can combine, they have all possible combinations between the two tables. Of course, it's not very meaningful at this stage because what's really useful is the join operation. But before we look into the join operation, we need to understand how does computer create, how does computer do in the background of the join operation. So the two operands do not have to be type compatible because it simply tries to create all possible combinations of the two tables mixed together. So think about this. Saying that department has 4 attributes with 3 tuples. So we have 3 departments. We have department number 1, department number 4, and department number 5. And department location has 2 attributes with 5 tuples. Think about this. If we try to do a Cartesian product between the two tables, department and department locations, first of all, how many attributes does the new table will have? So the new table will have 4 plus 2 attributes. And how many tuples were created if we Cartesian product these two tables together? We will end up with 3 multiply 5, which is equal to 15 tuples. So this is the tables I'm looking at. So if we focus on department as well as the department locations, you can see that we have 3 tuples with 4 attributes for the department. And for department locations, it has 5 tuples with 2 attributes. So if we Cartesian product the two things together, we will end up with a table with 6 attributes, 4 from the department, 2 from the department locations, as well as 15 tuples for the new table. So how do we creating 15 tuples? What it will do is that it will have research and then append the first row of the department locations. Then you will go into administration, append these 2 informations in back of it. Headquarters, append the first tuple from department locations in back of it. And then you will repeat the whole process. Research, append with the second tuple, administration, append with second tuple of the department locations. Headquarters will append second tuple of the department locations, and you will keep doing that. And therefore, you can see this is actually a nested for loop that combines the two tables together to create all possible combinations. So how do we do this in Oracle? How can I prove that what I told you guys is true? Basically, we simply go into the Oracle and write a code. So how can we represent a Cartesian product in Oracle? It's simply a comma. So what I try to do is this. When we try to do the Cartesian product, that's what we just said, department locations, if we want to Cartesian product them together, we simply put 2 table names in the from part, because from is indicating which table that you want to work with, and then separate that by a comma, then it will generate a Cartesian product already. So that's really put this into action and then see what's going on. So let me copy and paste this code without a semicolon, go back into the code, copy and paste over here. When I put a semicolon and hit enter, what you will see is that it will create a table. First of all, take a look at this one. It will have 15 rows, indicating it has 15 tuples, just as we have discussed. So if we go back to where we caused it, you can see that first of all, the table will have 1, 2, 3, 4, 5, and 6 attributes, and you will end up with 15 tuples as it has indicated. You may be curious that why does the Oracle did not display the outputs in a nice way. As I mentioned earlier in the previous class, this Oracle command line is actually not designed for showing the results, but it designed for the easy of the using for the query codes. That's why it does not look well right now, but later when we learn more, while we know how to select the interesting information that we are interested in, as well as do the join operation, it's not going to look as bad as it is right now. And therefore, you can see that it is really creating a Cartesian product by simply go in here and then use the comma, and so that we will be able to do a Cartesian product already. Let's take a look a little bit more information as well as the examples, and then we will move into how can we make that useful. So here is the question I want to ask you guys, and I want you to think about this. If a Cartesian product dependence with employee, the result will be how many attributes and how many tuples will be generated. That's the question. So again, the question is indicating that if we go into the information table, the tuples, if we Cartesian product employee as well as the dependent, so two tables being Cartesian product together, how many attributes is the end result of the table, and how many tuples will it generate? So you can see that for the dependent, it has 5 attributes. For the employee, it has 10 attributes. So the new table will end up with 5 plus 10 attributes. How many tuples will it generate? We have 7 over here, and we have 8 employees over here. So it will end up with a 7 multiply 8 equal to 56 tuples. So obviously, it's going to be a huge table. And therefore, and see that it will end up with 15 attributes as well as 8 multiplied 7 tuples. So it is going to be a big table for us to see. Therefore, again, if we want to do the real operations, we can really operate that. So take a look at this. If we go back to Oracle and then we select star from dependent as well as the employee, hit a semicolon over here, it first of all will end up with 50 tuples. That's what we have seen, and the table will end up with 15 attributes over there. So you can see that this is actually end up with a large table that we have seen over here. The question is, how can we make that useful? So if we try to Cartesian product the dependent with the employee table, what kind of things can we find it out? The answer is this. Take a look of the dependent table. Obviously, this is a weak entity. It has the ESSN indicating that who is the employee that this dependent depends on. So saying that, I want to find out what's the name of the employee that this dependent depends on. So obviously, if we look into this table, we cannot know the name of this employee, because all I know is this employee has a social security number 333445555. If you are, as a human, look into this table, you will be able to find that person is Franklin Wong. But because we use this information to map with that information, so we can have the people's name being searched out over here. Now, think about this. How does computer be able to know that? So what computer will do is this. It will do a Cartesian product between dependent and employee. So every single one of these, first of all, will append John Smith to the end of it. Since the social security number 333445555 is not equal to John Smith, none of this, John Smith will match over the last 3 dependents. So when it tries to see if I'm able to map with every single employee over here with the same ESSN equals to that SSN, then that is the information I'm interested in. If they are not matched to each other, those are not useful. The Cartesian product simply generates all combinations, but not all combinations are interesting. So we only want to find out the information that we are interested in. So you can see that in the first iteration, every single dependent here will append with John Smith and with the social security number another 10 attributes in back of it. So only when ESSN equals to SSN that we have appended, then that is the information we want to keep. Otherwise, we want to filter them out. And therefore, you can see that John Smith will be able to map with these 3 persons. So we will know that Michael, Alice, and Elizabeth are dependents of John Smith. Then others, since John Smith is not the employee that depends on, then they will be filtered out. Next, we will map with the next one, Franklin Wang. So we will have all of the information appended in back of each one. Since first 3 dependents has mapped the same social security number over there, then we will know that they are mapping the employees that we are interested in, while others, Abner mapping with Franklin Wang is not a match. Michael is not mapped with Franklin Wang, nor Alice or Elizabeth. So this process will keep going, and we only want to keep the ESSN of dependent equals to SSN of the employee. So that is how we will be able to make it useful. And therefore, you can see that while we do select star from dependent and employee, if we have a semicolon over here, we'll end up with a big table, and many of those information are not useful. So what we want to add is saying that where ESSN equals to SSN. So what it will do is that it will end up still a table with 5 plus 10 attributes. The number of attributes is not changed since we do select star. So it will still end up with 15 attributes, but only 7 tuples which ESSN of dependent matches employee SSN. And that is actually the idea of the join operation. So basically this operation is acting like appending corresponding employee information to each dependent. Let's take a look of how this is going to work. So if I copy and paste this code over here, and when we hit enter, first of all, you can see that 7 tuples is really created. And if we go back to where we cause it, you can see that this table will have still 15 attributes over here, but everyone, so you can see that Elizabeth will have all of the information, and then it will be able to map with the John Smith over here because they have the same social ESSN equals to the social security number of the employee over here. And it's the same thing for the next one, just say Elizabeth, you have this is the person who has the employee will map with this person. So it is going to, John Smith is appended to the Elizabeth information. So that is how we will be able to make Cartesian product useful. So finally, let's take a look of the another example, which is still doing the same thing. We saying that we try to Cartesian product department and department locations. We already know that you will end up with a table with a lot of information that are not very interested. So how can we make that useful? Again, department, take a look of this table. Department is here and department locations is here. So this try to store what departments located in what city. If we only look into this table, you can see that department number 5 located in Bellaire, Sugar Land, and Houston. Saying that we want not only department number 5 information, I want the name of the department. By looking into this table, department locations, you cannot find the name of the department. And usually name of the department is something that we know about. Just like social security number, you probably don't know your best friend's social security number, but you know the name of your friend. So we need to join these 2 tables together so that we will be able to map, say, 5 Bellaire, and then be able to map the 5 research department department number, 5 manager social security number, and manager start date, be able to append those informations in back of each tuples that we have. And therefore, that's how we will be able to find the information that we are interested in. And that's how we would be able to do select star from department and department locations. So we will Cartesian those two tables together. And now we need to set up our where condition. And you can see this where condition is a bit longer. Why is that? Because department number with the key attribute is using the D number. And department locations is also use D number as part of its primary key, and that's actually forming the foreign keys to link each other together. So if we say D number equal to D number, Oracle will get confused. It will not be able to understand which D number are you talking about. And that's why when the names are the same, we need to provide department.D number equals to department locations.D number. Take a look of the previous one. In the previous slide, you see ESSN equal to SSN because ESSN is the attribute in the dependent and SSN is the attribute in the employee. They are having different names, so Oracle can identify that. Of course, you can still write dependent.ESSN equals to employee.SSN over here to make it more specific, but it's actually doing the same thing. And therefore, like I said, for the department and department locations, because they both using the number over there, and that's why you need to provide a little bit more details to make sure that Oracle understands it. And therefore, you can see that if we try to execute a code over here, we will be able to find the informations that we are interested in. So let me try to do that. So if I hit copy and paste the code and hit semicolon over here, what you can see is that we will end up with only 5 tuples, and we have headquarters, department number 1, manager, as well as starting date, and then you will say that D number, which is coming from the department location table, Houston. So you will know headquarters located in Houston, administration located in Stafford, research located in Blair, research located in Houston, research located in Sugar Land. And that is how we would be able to make Cartesian product useful by adding a where condition.